The last problem, the lunchtime example. So this one I pick another problem is because I want to show you that the average doesn't have to start at 0. So take a look. Suppose the average amount of time it takes a student to finish a lunch is between 10 and 55 minutes. So in this problem, you have A equals to 10 and B equals to 55. So when you draw your graph, let me do the PDF first. So that will be 1 divided by 55 minus 10. That is 1 over 45. That is the height of the rectangle. 10 and 55. And then this is 1 over 45. So now we have a rectangle that doesn't start at 0. And then this is the PDF. The domain is x is any value between 10 and 55. And how do you show that the area is equals to 1? The base is 55 minus 10 times the height, that equals to 1. So we have area equals to 1. And then in part B, we find the expected value. So the expected value is 1/2. And then A plus B, 10 plus 55 divided by 2, that is 32.5, and this one is in minutes. And then the variance is 1 over 12, B minus A squared, 55. So that is 1 over 12, 55 minus 10 squared. And then you do all the math. This is 168.75. This is in minutes square. And then the standard deviation, you take the square root of the variance, the square root of 168.75, that is approximately 13 minutes. So that is the basic setup of this uniform distribution problem. And then in part C, I asked the probability that a randomly selected student can finish a lunch in at least 30 minutes, at least. So that is probability x greater than or equal to 30, at least, right? So that would be a 30 or above. And then we draw a graph. So let's push this up. We draw a graph from 10 to 55. And then this is 1 over 45. We have our rectangle. And then 30 is around here, 30, right? And then this is the area that we are looking for. So the area, what's the area? The base times height. So the base is 55 minus 30. The height is 1 over 45. So you have 25 divided by 45. That is approximately 0.5556. Okay? And then D is at most 25. So probability at most means the maximum is 25. So you have this from 10 to 55, and then this is 1 over 45. All right, 25. And then less than or equal to, we have that. Okay, and then what do we have? We have 25 minus 10 times 1 over 45. That is 15 divided by 45, which is 1/3, right? 0.3333. So that is A and D. What is E? E is the probability that a student can finish a lunch more than 40 minutes. So D is straightforward. Probability that x is greater than 40. Actually, we don't care about the equal, right? Because x is a continuous random variable. Okay, draw a graph as always from 10 to 55, and then 1 over 45. We have that. And then 40, this is a 40, greater than 40. We have this. So this is 55 minus 40 times 1 over 45. So that equals to 15 divided by 45. This is around 0.3333. And then part F is no more than 27. So part F, no more than, the opposite of more than is less than or equal to. 27. As always, draw a graph from 10 to 55. I hope that I can just copy and paste, but choose not to go that way because I really have to push you to draw the graph yourself. 27. So we have a 27 and then we shade the region. This is a rectangle. The area is base, which is the big number minus small number because you don't want negative, times 1 over 45. That is equals to 17 divided by 45. That is around 0.3778. And then part G, find the probability that a randomly selected student can finish a lunch between 15 and 34 minutes. So G is probability that X is between 15 and 34. We don't care about the equal because X is a continuous random variable. So I just answered the question. Inclusive, exclusive is not important because X is a continuous random variable. Draw the graph from 10 to 55. And then this is 1 over 45. We have 2 dots from 15 to 34. And then we shade this region. Alright, so that is 34 minus 15 times 1 over 45. So that is 19 divided by 45. That is around 0.4222. We box both. So that will be the probability question. And then next, we have to deal with some conditional probability. So in part H, let's zoom in. So part H is given that a student has spent 22 minutes to eat a lunch. Find the probability that this student can finish the lunch in less than 42 minutes. Okay. So in part H, probability given that has spent 22 minutes. So after 22 minutes, the lunch is not finished. The person is still eating. So this is greater than or equal to 22. That means the clock is still ticking. Find X less than 42. So since this is a conditional probability, we have to change the PDF to what? F of X is equals to 1 divided by, let's draw the picture first. From 10 to 55, this is what the problem gave you. There is no way to change these two numbers, but we are not going to mark the PDF right now. Let's draw the rectangle. This is given greater than 22, find greater than 42. So this is the area that we are looking for. So go back to the change of the PDF, then you are taking the maximum minus what? Minus the minimum. It's not just the minimum, it's minus the given. Whatever is given, you subtract it. Minus 22, so f of x is now 1 divided by 33. So the 33 goes right there, 1 divided by 33. Alright, and then we go back to the pink. Now we solve the problem. So this is 55 minus 42. How come we are not using the 22? Because greater than 42 covers the 22. So they are actually independent. Greater than 42 covers the first event. So we only need 55 and 42. And then times 1 over 33. So you have 20 divided by 33. That is around 0.6061. That is your answer. And then the next one, suppose that a student has spent at least 18 minutes to eat a lunch. Find the probability that this student can finish the lunch using more than 30 minutes. So more than 30 minutes. All right. So we have part I, probability given that x is greater than 18, find x greater than 30. So do the graph from 10 to 55. And then this is, nope, we are not doing anything right now because we have to change the PDF. So we have to change the PDF So this is f of x equals to 1 divided by 55 minus, let's go back to the picture. So from 10 to 55, we got it. And then greater than 18, greater than 30. So this is greater than 30. What do we subtract? We subtract this. We subtract the given, the 18. So this is minus 18. So we have 1 over 37, and then this is 1 over 37. So that's the PDF. And then now we answer the question. We take 55 minus 30 times 1 over 37. So we have 25 divided by 37. That is around 0.6757. So that's how you answer a conditional probability. Whenever you have a given, you take the biggest number, subtract the given. That's how you change the PDF. Because this is x greater than 18, I don't care about the 10 anymore. I already know that x is greater than 18. So the minimum is now 18. All right. So we have 2 parts left. The next one is find the 20th percentile. So that is part J, the 20th percentile. So first we draw a picture. From 10 to 55, we are not doing conditional probability. So we are not changing any PDF at this point. So this is go back to where? This is going back to the 1 over 45. The 20% means the first 20% of the rectangle. So this is k minus 10 times 1 over 45 equals to 20%. And then you just solve this equation. You multiply both sides by the denominator. So k minus 10 is equals to 20% times 45. So 20% times 45, then that will be 9. And then k minus 10 is equals to 9. So obviously, k is equals to 19. So k is equals to 19. What does that mean? That means the probability that the student can finish a lunch between 10 and 19 minutes is 20%. Again, the probability that a student can finish a lunch between 10 and 19 minutes is 20%. All right, last one. Okay, the upper 36, when you see the word upper, that means 36% on the right side. This is like, if you talk about this in terms of exam score, it's like the top 36%, the best 36, the highest 36% score. So that's what the upper mean. From 10 to 55, you have 1 divided by 45. From 10 to 55, 60%. So let's cut 36% right on the right side, and this is k. So we have 55, always big minus small, because we cannot allow any negative in probability, times 1 over 45 equals to 0.36. So 55 minus k equals to 0.36 times 1, no, it's not 1 over 45, my mistakes, is 0.36 times 45. So that equals to 16.2. And then 55 minus k equals to 16.2. So k is 55 minus 16.2. K is equals to 38.8. That is in minutes. So that is 38.8 minutes. So that means the probability that the student can finish a lunch between 38.8 and 55 minutes is 36%. Again, the probability that the student can finish a lunch between 38.8 and 55 minutes is 36%. All right, so that would be all for these examples.